I hope you remember the procedure. So to expand this about z equals 2, that is, unmute and speak up, I can't see my screen. That is in powers of z minus 2. The starting point is we put z minus 2 equals h. If 2 was negative, then we would have z plus 2. So if you're expanding in powers of z plus 2, you set or put your z plus 2 equals h. But let's concentrate on this example. We put z minus 2 equals h. So we're doing some substitution. That means z will be equal to h plus 2. Once you have this, you go back to your function f of z, then substitute z equals h plus 2. In place of z, use h plus 2. So our f of z, which is z over z plus 1, z plus 2, will be equal to, in place of z, we use h plus 2. So in the numerator, we have h plus 2 divided by h plus 2 plus 1. Z plus 2 will be h plus 2 plus 2. Moses and Stephanie should be quick. Anyone who has my contacts should be quick to notify me if I'm not in class. Now I could be talking to myself. That's the issue with online. My internet is not that stable. We simplify the denominator. H plus 2 divided by h plus 2 plus 1. 2 plus 1 is 3. So we have h plus 3. The other bracket will have h plus 4. So this is our function. But remember our starting point, we are starting from setting z equals to h plus 2, but eventually we need to expand this in powers of z minus 2. So at the end of the day, we will have to go back and substitute your h as z minus 2. Because when we do this, we're going to first decompose this into partial fractions. Once we do that, our expansion will be in terms of h. We'll have a function in terms of h, but we need to go back to what our h was equal to, z minus 2. So that's what we'll do at the very end. So h plus 2 over h plus 3, h plus 4 is a. We decompose this a upon h plus 3 plus b upon h plus 4. Multiply by the LCM, which is h plus 3, h plus 4. So on the left, we'll have h plus 2 equals a into h plus 4 plus b into h plus 3. Again, there's two ways to solve for the constants and b in this case. You can either use particular values or you can use a method of comparing coefficients, whichever way. If you choose to use particular values, you just look for a value of h that would set one of the brackets equal to 0. Make sure you use it on both sides, both the left and the right side. Do not forget to use it on the left side. So for instance, if we use h equals 4, then on the left we have 4. No. If h is negative 4, if I want to send the first bracket to 0, so if I use h is negative 4, on the left I'll have negative 4 plus 2. So the first bracket goes to 0. The second bracket we have b into minus 4 plus 3. Negative 4 plus 2 is negative 2. b into, this is negative 1. Negative 2 equals negative b. In other words, our b is equal to positive 2. We can also use h is negative 3. putting h equals -3. On the left, we have h plus 2, so -3 plus 2. -3 plus 2 equals a into the second bracket will become 0. On the first bracket, what do we have? A into -3 plus 4 simplifies to -3 plus 2 is -1 equals A. In other words, A equals -1. We don't have to use the other method because you know it, but whichever method you use, you should be able to get A is -1 and B is +2. So our function, which is h
Excuse
plus,
me?
sorry?
I think A is +1.
A is +1.
Oh, I've seen it. Thank you, Nimeona.
It's -1, right? So we have
No,
h plus 2 over h plus 3, h plus 4, which was equal to A over h plus 3 plus B over h plus 4 will be the same thing as A is -1 over h plus 3 plus our B is 2 over h plus 4. Remember, I advised you yesterday, you can always start with a positive fraction. So we start with 2 over h plus 4 minus 1 over h plus 3. Once you have the partial fractions, the next thing you want to do is you want to do some manipulations, algebraic manipulations, such that you end up with either a 1 plus something or 1 minus something. If it's z, so you either want 1 minus z or 1 plus z, and then you use the expansions for the binomial expansion for 1 minus z or 1 plus z. So how can we manipulate the first fraction so that we have a 1? In this case, it's plus. We are looking for a 1 plus something like a h in this case. How can we manipulate the first fraction?
Divide by 4.
So, and you have to communicate this even in the exam. Dividing through by 4, dividing, you can say through, or dividing both the numerator and denominator by 4 in the first fraction. What do we do? How can we manipulate the second fraction? And we divide by
3.
Calvin, and by 3 in the second fraction. The second fraction, once you communicate, you have to perform what you're talking about. So you're dividing through by 4. 2 divided by 4, that's the numerator for the first, divided by h over 4 plus 4 over 4 minus, here we're dividing by 3, 1 over 3 over h over 3 plus 3 over 3. If you simplify this, the first part, 2 divided by 4 becomes a half. So you have a half divided by h over 4 plus 1 minus a third divided by h over 3 plus 1. So for the denominators, you can rearrange so that you start with the 1. So this is equal to a half divided by 1 plus h over 4 minus a third divided by 1 plus h over 3. So we can make it look like this is a half times 1 plus h over 4 raised to -1 minus a third times 1 plus h over 3, the whole thing raised to -1. We're now good to make use of the expansion for 1 plus. In this case, it's h. So for the first, we'll have a half into, we'll have 1.
We can't hear you.
Network unamsikia ama ni mimi ndo siko?
We are also floating.
Acha nitumie time fulani imetumiwa hapa asubuhi nimpigie simu.
Hello, madam. We can't hear you.
Sasa mkiambiwa online ni mbaya msikii.
Had you guys written this? I hope I'm back
Yeah,
in the
this was
meeting.
the last part. Yeah, continue from there.
So this is a half times. So what do we have in this bracket? You know the formula. What do we have here? Calvin?
The Maclaurin expansion for 1 over 1 plus h over 4.
What is the formula again?
In sigma notation or the
Oh,
infinite series.
yes. Yeah.
So you have 1 minus h over 4 plus h over 4 all in brackets squared minus
H over 3 cubed. You can stop there. We expand the second part.
h over 4
Sorry. H over 4 cubed. Just a sec. I need to pick an eraser. This is why I hate online. Never shall I ever do an online class again. Yeah, this is tricky. Okay, just correct it in your books. My eraser is not working. Okay, that's fine. H over 4 cubed. Minus a third, we expand the second bracket. 1 minus h over 3 plus we have h over 3, the whole thing squared, minus h over 3 cubed, and so on. But remember, we need our answer in terms of z. We were dealing with the function f of z. So we have to substitute back. Our h is z minus 2, right? But first we could try to simplify this. We can try to collect like terms first, then substitute our h at the very last step. So we have a half into 1 minus h over 4 plus h squared over 4, h over 4 squared plus h over 3 cubed over 4 cubed minus h over 4 cubed. So let's try to collect the like terms. The constants, we will have a half minus a third. Maybe let me just open the brackets. I want you guys to see everything step by step. So if we distribute the half in the first bracket, then we have a half minus h over 4 times a half should be h over 8 plus h squared. 4 squared is 16 times 2. That should give us 32 minus h cubed. 4 cubed is 64 times 2, 128. We can stop here. So we distribute the third in the second bracket. We had minus a third Minus a third times 1 is minus a third. Minus a third times h times minus h over 3 will give us positive h over 9. Here we'll have minus a third times h squared over 3 squared should give us minus h squared over 3 times 9 minus h squared over 27. Here will be a plus. What do we have here? H cubed over 81. So let's try to collect the like terms. So we have the constants a third a half minus a third. So this is a half minus a third. For h, what do we have? We can factor out the h. What do we have here? One over 8 minus 1 over 9 h for h squared. One over 32 minus 1 over 27 h squared. Can even stop there. You don't have to proceed. What is a half minus a third?
One over 6.
1 over 6 minus 1 over 8 minus 1 over 9 h minus. Now you can notice that 8 is the same thing as 2 raised to power 3. Actually, we didn't need to expand the h over 4 squared and the h over 3 squared. But anyway, whichever answer is correct, you can have it in this form or whichever form. Thing is, you need to substitute back your h. So if you say this is 2 power 3 and this is 3 squared, so 1 over 6 minus 1 over 2 cubed minus 1 over 3 squared times h minus 1 over 32 is 2 power 5 minus 1 over 3 cubed h squared. Still okay. If you leave it as 1 over 8 minus 1 over 9, then times h outside, it's still fine. But we don't need our answer in terms of h because we had our z. We started by putting z equals z minus 2 was equal to h, or h is equal to z minus 2. So in place of h, you put z minus 2. In place of h squared, you put z minus 2 squared. If you have a third term, h cubed, you put z minus 2 cubed. So that is what we mean by in powers of z minus 2. So the answer should look like 1 over 6 minus 1 over 2 cubed. You can still have it as 1 over 8. It's the same thing, 3 squared times h is z minus 2 minus 1 over 2 power 5 minus 1 over 3 cubed times h squared is z minus 2 squared.
Excuse me.
Yes.
Where we were collecting the like terms, the last term, can we check on the signs? I feel like
Which term?
where we had minus into bracket 1 over 32 minus 1 over 27 h squared.
What is supposed to be the sign?
I thought it will be minus Okay, the 1 over 27 is a negative.
Mhm.
So when you put a negative outside the bracket, so it makes it positive, and yet it was negative in the series.
Can you just write afresh?
Sorry.
Let's just distribute afresh. We had a half into. What did you have? The person asking the question, what did you have initially?
In the
One?
series,
Yes. Before distributing their half.
before distributing the half, okay, we had 1 minus h over 4
Minus h over 4.
plus h over 4 everything squared minus h over 4 cubed everything.
Stop there. Then we had minus a third.
Yes.
Let's distribute this half before we go to minus a third. So this is a half h minus
H
h
over 8.
over 8 plus
No, it's just
h.
a half. No, it's a half, not a half h. The first term. No
Oh,
h.
yeah, it's half. This is a half minus h over 8 plus
Plus
h
h
cubed.
squared. H squared over 32.
No, h squared is not over 32. 16 times 2, oh yeah, 32, minus h
Minus
cubed over 64.
120.
4 cubed is 68 by 2, 128.
128, yes.
Okay, we go to the second term. We had a third. Just distribute, we don't have to write. If you
Okay,
distribute the third, you have a third.
plus okay, negative a third. We had negative a third in the first
If
place.
we just distribute the third into the second term before taking care of this.
Okay. A third.
Mhm.
Minus plus h squared over 9. No. Okay,
Now we want to
plus h
subtract the
cubed
two. We
minus
take
h
the
cubed.
first one,
Yes.
subtract the second, term by term. So first
But
constants, we have a half minus a third, right?
yes.
Then for the second part, we have
1 over
it's a
1 over 8
minus h over 8. Or you say, okay, you want us to factor the h outside. So you have 1 over 8
minus 1 over 9 into bracket h.
but we have a minus. We are taking the first term, terms in the first series minus the terms in the second series. So it's this minus this. So a half minus a third. Here we have minus h over 8 minus h over 9.
So that becomes plus.
So you have minus 1 over 8 minus 1 over 9. So plus 1 over 9. But if you factor out the negative, it means this sign will change, right?
Yes.
So we can rub this, just factor out the negative, and then inside we have 1 over 8 minus 1 over 9, so that if we distribute, we go back to minus 1 over 8 plus 1 over 9 times a h, isn't it?
Yes, that's okay.
If we go to the third term,
Yes.
we have a plus h squared over 32 minus h squared over 27. If we factor out a negative, what do we have?
That's where I got lost. So
Okay, let's just write it down. Oh yeah, you are having an issue with the third term, you remember, so we are having h squared over 32 minus h squared over 27. Actually, we don't have to factor out a negative, so this is a half minus a third. Here we had a minus 1 over 8 minus 1 over 9 times the h. Here it's plus 1 over 32 minus 1 over 27, h squared outside.
Okay, that's okay. So in the equation that you wrote above, where you have a positive, a plus here, it was minus.
Okay, thank you for that observation.
Okay.
This was reducing to 1 over 6 minus 1 over 8 minus 1 over 9 times our h is z minus 2 plus 1 over 32 minus 1 over 27. Our h is z minus 2, the whole thing squared. If you leave your answer at this stage, it's still okay. If you wish to go ahead and check what 1 over 8 minus 1 over 9 is, 1 over 32 minus 1 over 27, then you plug in the answer, it's still the same thing. Thing is, I want your answer in terms of powers of z minus 2 which appear. So I hope that's okay. That is the procedure to be followed. It's not all the time that you'll have a function. In this case, we had a z over z minus 1, z, okay, whatever, plus 2. In other cases, you will first have to start by factorizing the denominator. If you have something like, let's say, z squared minus 3z plus 2, you first have to factorize this so that you have your two brackets, then proceed to partial fraction decomposition and so on. But that's what you do. If you're doing the expansion about the point z is 0, you don't have as much work. You only start with partial fraction decomposition. Sometimes you might not need to go the partial fraction way, because if they just give you a function like 1 over z minus 2, then they ask you to expand this about, say, a point z equals 0. You don't have to do any partial fraction decomposition. You're just you're starting from manipulating this so that you have a 1 minus z or a 1 plus z. Then you use the binomial expansion for 1 minus z raised to negative 1, or 1 minus z raised to positive 1 plus z raised to negative 1. We can now look at Laurent series, how to expand a function in Laurent series. Before I give an example, for Laurent, you will be given modulus of z, say, less than something. But the requirement is that for you to expand a function using the binomial theorem, then it's only valid for modulus of z is less than 1. So for questions on applying expanding functions in Laurent series about, you'll be given the restriction. So for Laurent, your starting point is you look at your modulus of z. Is it given as less than 1? If it's given to be less than 1, you proceed to algebraic manipulations. If it's not less than 1, then you have to do what you go to do. If you have modulus of z less than, let's say, a, the requirement is we need modulus of z less than 1. So our starting point will be divide through by a, divide by a. Then you have modulus of z divided by a is less than 1. So once you have this, then you can now go back to your function. But now in this case, you'll be doing algebraic manipulations such that you arrive at either 1 minus z or 1 plus z, with an extra requirement that you should have a z over a appearing. So if I had something like 1 over z minus 2, but I was given the condition modulus of z less than a. So first step is I divide through by a so that I have the condition modulus of z less than 1. Now I'm having a z over a. I want to manipulate this function such that I have a z over a appearing somewhere. So how to arrive at that? Obviously, if you divide through by a, then you'll have a z over a appearing. But now you have to do it for both the numerator and the denominator. So you say 1 over a divided by z over a minus 2 over a. Does it look like a 1 minus z or a 1 plus z? It doesn't. So you have to do another extra step. So thing is, you can either do all the manipulations in a single step, or you could do it step by step so that you are able to track any errors or mistakes. But that's what you do. If our modulus of z is given to be greater than a, for binomial theorem, we require modulus of z greater than, less than 1. So you first start by dividing through by a so that you have a 1 on the right. So we have modulus of z over a is greater than 1, but we need less than 1. To change the inequality sign, if you reciprocate the left side, you'll have the required, the inequality symbol changing as desired. So if you reciprocate z over a, you have a over z. Mod a over z is less than 1. So the first step for Laurent, you'll always have to look at the region you're working with. Check that the modulus of whatever you're given should be less than 1. If it's greater, you know that to change from greater to less, you reciprocate. If you do not have a 1 on the right side, then divide through so that you have a 1 on the right side. Once you have this, you go to your function, you do algebraic manipulations such that you arrive at either 1 plus z or 1 minus z, with the additional condition that you should also have an a over z appearing. So this should guide you. First rewrite such that you have mod z less than 1, then whatever should guide your algebraic manipulations should be what is inside the modulus symbol. You can be given an interval. You'll be told, let's say a is less than modulus of z is less than b. If you have to expand a given function in Laurent series about an interval, you split the interval into 2. So the first part you'll have a less than modulus of z. Then you have modulus of z less than b. So you are having 2 conditions. You need both to be less than 1. So for the first part, a less than mod z is the same thing as if you rewrite starting with mod z, it's mod z greater than a. Divide by a so that you have a 1 on the right. So you'll have mod z over a is greater than 1, but we need this to be less than 1. So reciprocate, you have mod a over z is less than 1. For the second condition, mod z less than b, just divide through by b. Mod z over b is less than 1. And it's now in the right form. So you'll have 2 conditions which you'll use on your function. So for such cases, you'll always have 2 fractions. Whenever you're given an interval, you'll have 2 fractions. 1 over some first fraction, let's say z minus a plus b, maybe 1 or 2 or whichever. I'm just using 1 for the sake of explaining, but it doesn't have to be a 1 in the numerator. So if you have this and you're having modulus of a over z is less than 1, and then you have modulus z over b is less than 1. So in such cases, whenever you have an interval, you'll find that it's easy. You'll succeed in using one of the conditions in one bracket, exactly one of the fractions. you look at the two fractions. In which fraction can you easily, or are you likely to arrive at an A over Z easily? So if you were to use the condition A over Z less than 1 on this fraction, for example, whatever you do, there's no way you're going to arrive at an A over Z. There's no miracle you can perform to have an A over Z in this fraction. But if you come to this fraction, you can easily arrive at an A over Z because you have Z minus A. If you need A over Z, you simply divide through by A. Similarly, if you have this condition Z over B less than 1, you want to perform algebraic manipulations such that you are transforming into a 1 plus Z or 1 minus Z with the requirement that you have a Z over B appearing. So if you want to use this condition on the first fraction, on this fraction, there's no miracle you can perform for you to arrive with a Z over B. But if you use this condition Z over B less than 1 in this fraction, then Z minus B, clearly you can arrive at a Z over B, because Z minus B, if you divide through by B, then you'll have your Z minus B. So if you have an interval, first thing is split into two, rearrange such that you have two conditions which are both less than 1, and then check which one is applicable to which particular fraction. Once that is the case, you apply each condition on exactly one of the fractions, and then you do the expansions. So if we were to use this 1 over Z minus A, then plus 1 over Z minus B, and we are having the conditions A over Z, mod A over Z less than 1, then mod Z over B less than 1, automatically we are going to use mod A over Z less than 1 on the first fraction, because then we can easily arrive at an A over Z by dividing through by A. So if you divide through by A, you'll have 1 over A divided by Z over A minus A over Z. In the second fraction, we use the condition 1 over Z minus B. So Z over B, we need a Z over B. Z over B, we divide through by B. So 1 over B over Z over B minus B over B. We are having our A over Z appearing as well as our Z over B appearing. But however, we do not have a 1 plus Z or 1 minus Z. So we have to do an extra step. That is what I meant by saying you can either do the manipulations in a single step, or you can do stepwise. You can first concentrate on arriving at the conditions Z over A and Z over B. Then once you have that, you look at how can you transform this so that it looks like a 1 minus something. Z over A minus A over Z, if you multiply through by -1, then you'll have minus Z over A plus A
Over A.
A over Z plus A over Z. No, this one is not agreeing. Let me see.
Should be A over A.
But it should have been A over Z, right?
A over A.
Over A.
A over?
A.
This is A over A. We are dividing through by A. I made a small mistake here. So this looks like Z over A. Now let me just do this extra step. So this one is 1 over A over Z over A. A over A is 1 minus 1, right? Plus 1 over B over Z over B minus 1. The second part looks okay. No, does it? Doesn't. So if we need a 1 minus something, if we do divide by -1, if you multiply by -1, then Z over A and reactive Z over A. But that negative also affects the numerator. We have in the numerator -1 over A, something, so minus 1 over B minus Z over B plus 1. Then rearrange so that you have a -1 over A. So instead of doing this in 2 steps, you could easily say divide through by negative a in the first part and negative b in the second part. We're just doing a single operation which will help you arrive at the conditions as well as the right form 1 minus z. Or you could go step by step, first arrive at the conditions, then check how to make it look like a 1 minus or 1 plus. But whatever you do to the denominator to make it look like 1 minus or 1 plus, you have to also do it to the numerator. If you're dividing through by some constant, you have to divide through in both the numerator and the denominator. If you have to multiply by a negative or a positive, you do that. I think we can now give an example to illustrate this. But that's what happens. Can give examples. Let me see. So expand f of z equals 1 over z minus 2 in Laurent series for 1 modulus of z is less than 2. I think I can also give for greater than. Modulus of z is greater than 2. So that will illustrate all the possible cases. So we start with the first part. You start from the condition you're given. You're given modulus of z is less than 2. For binomial theorem to be valid, you need modulus of z less than 1. So divide through by 2, you have modulus of z divided by 2 is less than 1. We now have the condition as required. We need modulus of z over 2 is less than 1. So once you have this, go back to your function. Your f of z is 1 over z minus 2. So you want to manipulate this so that it's either a 1 over 1 plus z or 1 over 1 minus z. But you are having this in mind. Whatever you do, make sure you arrive with a z over 2. So what can we do in this case? You can just give a single manipulation that will transform it into 1 over 1 minus z, such that you'll have a z over 2 appearing, or you could go step by step. First, see how to arrive at z over 2, then check whether it's in the right form or not, then do an extra step. So what can we do in this case?
Divide all through by negative 2.
So yes, dividing through by negative 2. So we have negative 1 divide over 2 in the numerator. In the denominator, we have z divide by negative 2 minus 2 divide by negative 2. So this is negative half over 2. Minus 2 divided by minus 2 is positive 1. The next step, we just have to rearrange so that we have this is minus 1 over 2 divided by 1 minus z over 2. So this is negative a half times 1 minus z over 2 raised to negative 1. From here, you can apply the expansion for 1 minus z. So this should give minus a half into, should be 1, plus z over 2 plus z squared over 4 plus z cubed over 8, and so on. You can be stopping at the third power. You don't have to go so far. For the second part, part B, the condition is modulus of z is greater than 2. Again, your starting point is you have to manipulate this so that you have modulus of z less than 1. If we divide through by 2, we have modulus of z divided by 2 is greater than 1. But we need modulus of z less than 1. So reciprocate this and you have modulus of 2 over z is less than 1. Again, go to your function. Your function f of z is 1 over z minus
Check
2.
on your speed.
Sorry?
You're going too fast.
Sorry. Can I scroll up?
Yes.
To what point?
There. Okay, you can continue.
So for the second part, we are given mod z greater than 2. We need mod z less than 1. So you first make the right side a 1. For arrive at that, you divide by 2, divide through by 2. If you do that, you have modulus of z over 2 is greater than 1, but we need less than 1. So to get this modulus to get the inequality symbol to change, you simply reciprocate the left side. So if you have modulus of 2 over z, then the inequality will change from greater than to less than 1. So once you have these, you now go back to your function f of z. It's given as 1 over z minus 2. So you want to manipulate your function so that you have either a 1 plus over 1 minus z or 1 over 1 plus z. But having in mind that you also need a 2 over z to appear. So this should guide what you do. So how can we manipulate 1 over z minus 2 such that we either have a 1 over 1 plus z or 1 over 1 minus z with the condition that a 2 over z is appearing? What do we do? Divide by what? The denominator should guide you. Your denominator is z minus 2. How can you arrive at a 2 divided by z?
You divide through by z.
You divide through by z. If we do that, so dividing through by z, we have 1 divide by z in the numerator. Don't forget to divide through in the numerator. In the denominator, we have a z divided by z minus 2 divided by z. So this is 1 over z divided by z is 1 minus 2 over z. Is it in the right form? It is. It's a 1 minus something, right? So this is 1 over z into 1 minus 2 over z raised to negative 1. You can apply the formula for the binomial expansion for 1 minus z. If we do that, we have a 1 over z into 1. What do we have inside? The expansion for 1 minus 2 over z. What do we have? Am I still in class?
Plus 2 over z
Plus 2 over z
plus 2 over z all squared
2 over z squared plus
2 over z all cubed.
can stop there. You could go an extra step and say this is 1 over z into 1 plus 2 over z. You know 2 squared is 4, z squared is z squared plus 2 cubed is 8, z cubed, and so on, which is the required Lorentz series. Let me now give an example where you have an interval, also where you do not have the partial fractions in the first place, so you have to do all the donkey work. Part B, expand. No, I don't have to write the question. No, part C. I can just say part C. Expand f of z equals 1 over z squared minus 3z plus 2 in Lorentz series valid for 1 is less than modulus of z less than 2. So the function f of z is 1 over z squared minus 3z plus 2. And we're having an interval mod 1 less than mod z less than 2. So here our starting point is we have to first decompose our function into partial fractions. It's not all the time that we'll just have a simple fraction to work with. Sometimes you have to first decompose your function into partial fractions. Once you have the partial fractions, you can now go to, the restrictions. Split it into 2, then proceed to make the 2 conditions less than 1, and then check which condition are you going to apply on which particular fraction. So let's start by decomposing our function into partial fractions. Here we have to start by factorizing the denominator. Product is 2, sum is -3, so -1 minus 2. So our f of z, which is 1 over z squared minus 3z plus 2, is equal to 1 over, if we factorize this, z minus 1, z minus 2, right? Product is 2, sum is -3. That's what you get, right?
Yes.
So we now have to decompose this 1 over z minus 1, z minus 2 is a over z minus 1 plus b over z minus 2. Multiply through by the LCM. We have on the left, we have 1. On the right, we have a into z minus 2 plus b into z minus 1. We need to determine our the values of a and b. Maybe you guys can do this and tell me in 2 minutes. I need the values of the constants a and b.
A equals to 1, -1, and B equals to 1.
Is anyone done with, what are the values of the constants a and b? Just a minute, I'm trying to work on my screen. It's glitching on my end. Oh yeah, okay, there we go. A is -1, B is 1. So our function f of z which was A over z minus 1 plus b over z minus 2 will be minus 1 over z minus 1 plus 1 over z minus 2. Again, I'll always advise you start with the positive fraction. So start with 1 over z minus 2 minus 1 over z minus 1. Now we have the two fractions. We go to the restriction and work on it, then check which condition is applicable to which particular fraction. The restriction was 1 less than mod z less than 2. So again, I said you have to split this into two. So the first part is 1 less than modulus of z. The second part, we have modulus of z less than 2. Let's first work on the first part. So on the first part, we have 1 less than modulus of z. If you rearrange, it's the same thing as modulus of z greater than 1. But we need this to be less than 1. So what do? We reciprocate. So we have modulus of 1 over z is less than 1. We are done. It's in the right form. For the second part, modulus of z less than 2, we need less than 1, so divide through by 2. You have modulus of z over 2 is less than 1. So you have two conditions. In the function you have two. So you look at these two and look at how to manipulate your f of z such that you are either having a 1 over 1 minus z or a 1 over 1 plus z, with extra conditions that you are having a 1 over z and z over 2. So looking at the two fractions, let me just write them here. We had 1 over z minus 2 minus 1 over z minus 1. So in which fraction are we likely to arrive at a 1 over z? In other words, in which fraction do we apply this condition? And in which fraction are we going to apply the second condition? Look at the two fractions. In which fraction are you likely to arrive at a z over 2 so easily? In which fraction are you likely to arrive at a 1 over z without any struggles? So that should guide your choice of which condition to apply on which particular fraction. So where do we apply mod 1 over z less than 1, and in which fraction do we apply mod z over 2 less than 1? Guys, there's no rocket science here. Sam?
We'll apply condition 1 to the second fraction and condition 2 where mod z over 2 is less than 1 to the first fraction.
Correct. So what do? We need to apply the manipulations now. We're applying that condition. So how do we arrive at a z over 2? Dividing through by what? Because here you just have to specify you are dividing through by what in the first fraction, and in the second fraction, what exactly are you doing? That's what I want.
For the first fraction, so that we get mod z over 2, we'll have to divide both numerator and denominator by 2.
If you divide by 2, are you arriving at okay, dividing through by, are you giving a single step or do you want to do it step by step? Because if it's a single step, then we say divide through by this. If we're going to do it in 2 steps, then we don't have to say divide through by. For the first part, it will work, right? If you divide through by 2, do you arrive at a 1 over 1 minus z at the same time? You arrive at a z over 2 while at the same time meeting the condition 1 minus z or 1 plus z. Does it work? Some.
For the first fraction,
Yes.
we'll get 1 over 2 over z over 2 minus 1.
But does it look like a 1 over z, 1 minus z?
Yes, it does. We'll have to rearrange and maybe write 1 minus z over 2.
We are dividing through by what again? In the
By
first
2.
part? By
By
2.
2.
But
Yeah.
if you divide through by 2, we are having 1 over 2 over z over 2 minus 2 over 2. So z over 2 minus 1. That is a z minus 1. We need either 1 minus z or 1 plus z.
We can divide by -2.
Yeah, you divide through by -2. So dividing through by -2 in the first fraction, what do we do to the second fraction? How do we arrive at a 1 over z?
By dividing through by z.
Yeah, if we divide through by z, we have a 1 over z over 1 minus 1 over z. It's already in the right form. If we do that, we are having minus 1 over 2 over z divided by -2 minus 2 divided by minus 2 minus, in the second part, we are dividing through by z, 1 over z divided by z over z minus 1 over z. So this is going to be minus a half divided by minus z over 2 plus 1 minus 1 over z divided by 1 minus 1 over z. This screen. This is z, don't confuse it for a 2. So for the first part, this is minus a half. Of course, if we rearrange the denominator, you have 1 minus z over 2. Then this is raised to minus 1 minus 1 over z into 1 minus 1 over z raised to -1. So minus half into, what do we have in the first part? I just need the first 3 terms. 3 or 4. What's the expansion for 1 minus z over 2 raised to -1? Again, if it's 1 minus, all the signs will be positive. If it's 1 plus, you'll have alternating signs.
1 plus z over 2
1 plus z over 2
plus z squared over 4
z squared over 4
plus z cubed over
8 plus. So you have to say it continues and so
but
on.
is it 8 or 64? Oh, 2 cubed. Okay.
2 cubed is 8.
Yes.
Then we are subtracting the second one, minus 1 over z into 1.
Plus 1 over z.
Plus 1 over z.
Plus 1 over z squared.
Plus 1 over z cubed. Plus and so on. You say which is the required series? You can't simplify these two because on the first part you're having negative half into 1 plus z over 2, then here you're having a minus 1 over z into, so there are no similar or like terms. So you have to say which is the required series. If you don't say this, I snatch you a mark, which is the required Laurent series. So that's what you do. Given an interval, you first split it into two, check your two fractions, check which condition is applicable to which fraction, and yeah. Too easy. Booster subject. You guys will really enjoy your day one of semester one exams. Look at calculus of residues. You need to find singular points. We'll define residues, but we start with singular points. You can always check on my speed. A point at which a function f of z is not analytic is known as you have a function 1 over z minus 2, then it will have a singular point at z minus 2 equals 0, or at the point z is 2, because 2 minus 2 gives 0, which is undefined. 1 over 0 is undefined. Isolated singular point.
Nasema mke hello. Oh, a class. Good. Is it good morning? Lecturer amesema class ishia hapo. Arota is misbehaving and she is also leaving for another physical class. So you can all leave the meeting at your own time. Mama muendelee tu kukaa hapo.